Hi everyone, my name is Yasser, and this is part 2 of a video tutorial in which I show you how to use MATLAB and Simulink to interface with the LEGO Mindstorms NXTs. So let me show you my setup that I have here. So I have a 1 degree of freedom robotic arm, as well as a payload, which I'm going to use a wheel for. And the idea is the arm is going to pick up the payload and then drop it off at a destination located 180 degrees away. So I have two motors here. One motor is dedicated to rotating the arm, as well as another motor that is dedicated to controlling the gripper. The arm encoder I have connected to port A on the NXT brick, and the gripper motor I have connected to the port B on the NXT brick. And as well, I also have a USB connection that connects the NXT brick to my laptop that has MATLAB and Simulink installed onto it. So let's get started here.
Okay, so now I'm going to head into the Axis 2013 directory, and I'm going to execute the Axis program by typing in Axis, and that should bring up the main menu of the Axis 2013 software. So the two tools I'm going to be talking about today are SimLab and LEGO Lab. Now SimLab allows the user to simulate the NXT motor response, whereas the LEGO Lab allows the user to actually interface with the real life NXT motor and observe its response. So I'm going to go into LEGO Lab. I'm going to go to Experiment 5, Control System Design. I'm going to open the model. So here I have a closed loop position control for my 1 degree of freedom robotic arm. Now there's some things I can edit here. If I double click on the arm gripper control, I can set the drop position angle as well as the amount of time that the gripper waits before being activated. So I'm going to set this drop position to 180 degrees and the wait time to 1 second. And hit OK. Now I can also set the parameters of my PID controller by double clicking on the PID block. So I'm going to set a proportional gain of 5 with an integral and derivative term of 0. Then I hit apply OK. Next up, we need to check our Bluetooth connection. So go to Tools, Run on Target Hardware, Options, and ensure that the target hardware has been set to LEGO Mindstorms NXT. Additionally, make sure that the external mode has been turned on. Finally, check your COM port number and set it to the appropriate number that the computer is using to communicate with the brick via the Bluetooth connection. So my COM port number has been set to 4 because that's the COM port my computer is using. So once all that's done, I'm going to hit OK. And to run the program, you just have to go to Tools, Run on Target Hardware, and click on Run. So now Simulink is just compiling the program and uploading it onto the NXT brick. And once uploading is complete, the program should run on its own, and you'll start to see the robotic arm move. So once that's complete, you can see the position response located on the Axis 2013 front panel here. Now I can plot this response to a MATLAB figure by clicking Plot to Figure. And I can analyze this data by using the data cursor tool. And I can already see that the percentage overshoot of the position response is quite high. It's about 7 degrees. So let's say I wanted to redesign my PID controller to lower this percentage overshoot. But let's say I didn't want to go through the process of using the actual robotic arm. I can use the SimLab tool in Axis to actually simulate the position response of my arm. So I'm going to head into SimLab, and I'm going to go to Experiment 5, Control System Design, and open the model. So here I have a closed loop position control of the robotic arm. However, everything now is simulation based. So if you double click on the DC motor block, you can see all the parameters that characterize your particular DC motor. Now I've already determined the parameters that correspond to my motor. When you do this at home, you will want to experimentally determine these values for your NXT motor. So once you've done that, you can hit OK. And you can also set the PID controller values. So we said we wanted to lower the percentage overshoot. So I'm going to lower the proportional gain to 3 and hit apply OK. Now I can run the simulation by clicking Run Sim. And I can plot the response by clicking Plot to Figure. And you can see that the percentage overshoot has decreased to about 3 degrees or so, it looks like. So I'm going to save this figure so we can refer to it later on. And now I'm going to do the exact same thing but in LEGO Lab. And we can compare the motor response to the simulated response. So I'm going to head back to Control System Design, Experiment 5, open the model, and I'm going to adjust the PID gain now to 3 to match my simulated response. And hit apply OK. And then finally to run it, go to Tools, Run on Target Hardware, and click Run. So once again, Simulink is just compiling and uploading the program onto the NXT brick. Okay, so once that's done, I can plot that figure by clicking Plot to Figure. And I can compare the actual response against the simulated response by opening up the simulated response I had before. And I'll put them side by side. And you can see that the simulated response is very comparable to the actual motor response. So yeah, now you know how to use the Axis 2013 software to both simulate the motor response as well as use the LEGO Lab tool to find the actual motor response. And you can use both of these tools to do other experiments such as speed control, open loop speed, as well as open loop sine input. So that concludes this video tutorial. Hope you've learned something, and thanks for watching.